All right, everybody. So what we're going to be looking at today is like kind of an extra lecture that's going to specifically cover the homework 27 from the spring 2021 semester. That's because I'm writing that because I may use this video in the future, and maybe the homework numbering will change. So I really recommend that you watch this video to the end. It's got some stuff that you need to know. So let's go ahead and get started. So in a previous lecture, probably 26, I'm going to imagine, we learned a little bit about the definite integral. And so what the definite integral was an area. Well, that's the way we're thinking about it. So if you have a function that's positive, that didn't want that, that didn't want that. Why am I erasing? Stop erasing. Okay, there we go. So you've got a curve. So we'll call the curve y equals f of x. We've got an area that's between the curve, and also the x-axis. Okay, so it doesn't go down to the bottom of the page. Sometimes people get confused and they'll see a graph like this, and then if you ask them what area is the definite integral, they shade all the way down to wherever the graph stops. Right? That's not right. The definite integral is just the area under the curve, but between above the x-axis. And if you've got a function that goes below the x-axis, that goes negative, then that would look like this. I'll draw another one. We'll call it g, I guess. So if you've got one like this, there's a function, and you wanted to integrate from a to b, then what happens is you've got an area here, this area, but also you've got this area down here. And essentially what would happen here is this. So let's talk about these both momentarily here. So this top one here, if you wanted to calculate that area, then if this area is, let's say, capital A, then the integral from a to b, right, which are these numbers, of f of x dx is equal to, what is that equal to? That is equal to a. Okay. Now, if you've got a definite integral like the one I'm showing here, where these are going to be, let's say I call this area B and I call this area C, right? So I'm just using B and C because we already used A, so I'm using capital letters for these areas. If you wanted to calculate this integral from little a to little b of g of x, which is what I'm calling this function, then the way you would calculate it is you've got this area here above the axis, you have this area here below the axis, and the definite integral from a to b, which is what we have here, is going to be, well, basically the area here that's above the axis is going to count as a positive number. And the area down here that's below the axis is going to count as a negative number. Okay? And, whatever you get when you work that out could be positive, could be negative. That's going to be your answer. Okay? So if you knew that this area was, for example, let me just put a couple numbers on here. Like if I knew that this area was 2 and I knew that this area was like 4.5, for example, then the way you would calculate this integral is you would say, well, the positive area was 2 and the negative area was 4.5. And so the result would actually be negative 2.5. That would be your answer. Okay? And the reason I'm talking about this is because without doing any calculus to calculate this or to calculate this, if you have a reason to know what this area is, like if this area is 2 and this area is 4.5, then you don't need to do anything fancy here, right? If you know what these areas are, just put the numbers in and you will get the answer. Okay. So the first part of this homework assignment, it's dealing with definite integrals in this way, just as areas that you're going to know from the graph. Okay. So it's just the area. We defined this, right? This is the area between x equals a. Sorry, I don't want to write it that way. The area between the curve and the x-axis between x equals a and x equals b. And something that I mentioned last time was you could kind of insert this word net, the net area between the curve and the x-axis. And the reason I'm using that's bad color to highlight that with. Well, the reason I'm using net is because of this concept of a positive area and a negative area, so that you get a positive 2 but a negative 4.5, right? So net means we're dealing with some positives and some negatives, and you just get what you get when you add them up, right? So this integral is not 6.5 because this one's negative. All right. So I think we've said enough about that. Let's actually start to look at what we're going to be doing on the homework. So the idea for the first problem type in the homework. So the first problem type. So the idea is this. You are given a graph. Okay. And asked to compute a definite integral. All right. Now, what's going to happen though is, for reasons that will become obvious, you're going to know these areas. Okay. Since the definite integral is an area, since you will be able to find the area using basic geometry formulas, the areas on the graph, with basic geometry, that is the easiest and, in fact, only way for us to do these problems at this point. So that will be the easiest and only way to solve the integral. All right. So that's the situation that we're dealing with. And so all of the problems of this type look like this. So here's an example. I have to draw it. I can't copy paste it. So here we go. So this is going to be directly off of the homework. So I'm literally copying this graph. So we have that. That's a 4. This is a 2. Not going to be exactly square here. That's a half circle. Then we got way over here at 12. Again, I'm not drawing this to scale. That. And then up at 4. Call that halfway. Not that it matters. We got a little triangle thing. And then we got 12 and let's call it 18. I'm not counting boxes here, so say that would be up at 3 or something. Almost. Okay. All right. So we've got a graph that looks like this. And so this is up at height 3, by the way, just so we're clear. And this is what we have. And this area is shaded. So we've got here inside the triangle is shaded, and inside this is shaded. And so the two things that look like half circles are supposed to be exactly half circles. Okay. And so what they tell you is they've got this labeled as f of x. They have this one labeled as g of x. Uh, and then they've got this one labeled as h of x, like this. They give you the equations, which we're not going to use at all, but they give them to us. So f of x is 4x minus x squared, square root. G of x is 4 minus absolute value x minus 8. You know, absolute value function has this diamond shape. Usually you see it like this, but this one's upside down and moved over. H of x is another half circle, and it has a formula that's not a square root symbol. Hold on. Negative 216 plus 30x minus x squared. Interesting. Okay, so we have these. Okay, so the integrals of the function graphed in the figure into the sum of all shaded areas in terms of pi. So they give you all of this here, and they don't write an integral down, but the problem says something like use formulas for area to calculate, to evaluate the integrals. Right? Not shown. They did not tell us the integrals. I'm going to write them down in a minute, but they did not tell us what the integrals are, but nevertheless, they say use formulas for area to evaluate the integrals of the functions. And then they say enter the sum. So we're going to be adding up the areas. And they also say in terms of pi, which means we're not doing decimals or anything. Okay, so this is what you're given in this problem. Okay, and so this is not hard actually. So what I'm going to do is, first of all, what are the integrals? So you may have this question. You say like, well, what integrals? What integrals are they talking about? Well, they're talking about this. So we know that you've got a shape here, right? And a shape here and a shape here. The shaded area here corresponds to an integral, just like this does, right? So this first shaded area here is going to be an integral. So let me get a different color here. Green. So like if you wanted to know what this area is, as an integral, it's the integral of f of x dx. The dx is a non-optional part of this. This is just notation. And we are clearly starting from 0 here, going up to 4. On the x-axis, that's the a and the b. So that's the integral that we're doing. And if you wanted to put in the function, right, because we know what f of x is, of course, that's the integral from 0 to 4 of square root 4x minus x squared dx. All right, so this area right here, that is what the shaded area is for this first half circle. Okay, and similarly for each of these, each one of these is an integral. So I'll pick a different color. So like, what's this area? Well, same idea. It's an integral from, we're going from 4 up to 12. So that's 4 up to 12 of g of x dx. What's g? Well, we know that g of x is given here, 4 minus absolute value x minus 8. So parentheses 4 minus absolute value x minus 8 dx. I'm putting parentheses here because this dx is supposed to be on the entire function. Yeah. All right, and then you have one more. So you've got one more, pick a different color. We'll go dark green. So this one right here, this is an integral. We are going from 12 up to 18. 12 to 18, that 18, 12 to 18. That's, I don't know why that was so hard to write. 12 to 18. The function is called h, or if you want to put in the function, it's square root of all this. So negative 216 plus 30x minus x squared dx at the end. All right. So when they say evaluate the integrals and they didn't show you an integral, they're just saying each one of these areas is an integral. All right. So let me just write this down. So each area is a definite integral, or it can be written that way. So, right, the first one was, what was it, 0 to 4 of f of x, 4x minus x squared dx. The next one was 4 to 12, parentheses, 4 minus absolute value x minus 8 dx. Last one, 12 to 18, square root negative 216 plus 30x minus x squared dx. Okay, so each one is that. Now, we at this point do not know how to evaluate these integrals. And in fact, this integral here, this one and this one are, not something you could do in a Math 4A class. You would need to be in Math 4B to attempt the first or the third. So they do not expect you to use calculus on this, okay? You're not using any advanced techniques here. So what do they want you to do, right? How will we calculate them? Compute these. All right. How will we do it? Easy. The shapes, the actual shapes on the graph are half circle, triangle, half circle. And you know how to calculate the area of a half circle or a triangle, right? So the areas, or let me say this, the integrals are hard. But the area are easy shapes. Half circles and triangles, right? And so that's the key. Just if you know how to calculate the area of a half circle or a triangle, then you can solve this problem. So use those formulas. So use formulas for area. So like for a circle, the area is, of course, pi r squared. That's all. And, a half circle will be half of that, right? So if you wanted to add the word half, you would just add a half. Triangle, the area is 1/2 base times height, right? So you are supposed to remember these formulas from, previous math classes, basically. Okay, so with that in mind, let me just see if I can copy this here. How will I do that? There's a lasso. Duplicate. Awesome. So here's what we have. Just erase some lines. All right. So how are we going to calculate these areas? So for the first one, right? which I'll just call them f, g, and h. Now the formulas don't even matter. So let's compute them. So first thing you have is the integral from 0 to 4 of f of x dx. I'm not going to write out what f of x is. Now we know that that's a half circle with what's the radius of that circle. And you could figure that out here, right? Because like if this is 0 and 4, then of course the radius is 2, right? 2, 2, 2. So that's a half circle with radius 2. Okay? Now, how would you calculate that? Well, that's going to be, according to the formula, over here. It's going to be 1/2 pi r squared, and r is going to be 2. So it's just going to be 1/2 pi r squared, which is half pi r is 2. I don't know what happened to my pen there. Pi 2 squared. So you work that all out. This is 4. 4 times a half is 2. 2 times pi is 2 pi. So that's your first area, right? Nothing complicated to calculate that integral because it's just a half circle. Let's move on and do the triangle. So we got the integral from 4 to 12 of g. That's just going to be a triangle. What's the height and the base, right? With base, well, the base is just from here to here. So from 4 to 12, right? So that's going to be 8. So base is going to be 8. And the height of the triangle, you can calculate that. It's 4. You just look at the graph here. Triangle with base 8, height 4. So then you know that the formula for a triangle was 1/2 base times height. So 1/2, the base is 8 and the height is 4. So that's 1/2 times 8 times 4. So that's 16, right? Yeah, 16. Last one, 12 to 18 of h of x. That's another half circle, right? That's a half circle. The radius is r equals, well, it looks like 3, right? Because 12 to 18 is a distance of 6. And like the reason I wrote this 3 here, remember, was that was the height. So this is a half circle with a radius 3. So I'll just draw it like this. 3. So half circle with radius 3. So just like before, that's 1/2 pi r squared. 1/2 pi r is 3. So you get 9/2 pi. So 9 over 2 pi, I believe. Okay, so there you go. You've got these areas, right? And the actual answer to the question, if you scroll up, was enter the sum of the areas in terms of pi. So enter the sum. We need the sum. They ask for the sum. They say enter the sum. So our actual answer is going to be the 2 pi that we found plus the 16 plus the 9/2 pi, which you can write lots of different ways. I'll write it 4.5 pi. So what do we have? We have 6.5 pi plus 16. I'm going to type that in and see if it likes it or if it has a problem with my decimal. Where is the pi symbol? There it is. Right. Awesome. Okay, so here's the next question. It's almost the same, but it's slightly trickier here. So let's do the next question in the homework. So it says evaluate 2 to 6 integral 4 minus x minus 4 squared dx. They say they tell you what to do. They say using the formula for the area of a circle. All right. So here's the thing. You might look at this and not know what this looks like, right? But they did tell you it was supposed to be a circle. I'm just going to go to Desmos and we'll plot this real quick. Uh, let's just plot the function. What's the function? The function was y equals square root 4 minus parentheses x minus 4 squared. Okay, what's that look like? We already know it should be a circle. So going to do that. See if I can do this. Got Twitter and Amazon up. Let's go Amazon. Desmos. Graphing calculator. All right, so let's type this in. So if I type in y equals, and we're looking for this function, I need a square root. Where's that? Square root 4 minus parentheses. Where is x? X minus 4 parentheses squared. All right, so there you go. There's your graph. And, hopefully you can see why they said from 2 to 6, right? Because they just want the area under this curve. So like if I actually, I can even make it graph the area if I want. So like I'd have to do it like this, like that. And then over here, put a 0 or something. So that's actually the area that they're talking about, the area between 0 and the circle. You don't have to do that, right? I can just delete. Right, that's good enough. Well, not with that. Okay. You know what I mean, right? So we're talking about the area below, or the area that was previously shaded. So we're specifically talking about this. Draw it. 2, 6. That's the worst circle I ever saw. Let's keep scribbling and eventually it'll look okay. All right, so that's what we're talking about here. This looks like it goes up to 2, and this is a half circle. Okay, so all they want you to do here, that's what I should have done. All they want you to do here is find this area using geometry. So let me just copy paste this real quick. Why can't I do it? Okay, there we go. No, I can. Duplicate, come down here. So we're trying to find this integral right here, and we know that it's just using the area of a circle. So area of half circle again, still a half. What's the radius? Right? That's 2, right? Hard to see that. But from 2 to 6 is 4. So the radius is half of that, so it's 2. So 1/2 pi r squared again. And that is 2 pi. So that's as simple as that. Hopefully that's not like too tough because we just did it and we did it again. The hard part was they did not give you the picture this time, so you had to figure out the picture yourself. But that's what these graphing tools are for. So let's do another one. And this is another circle here, so this is probably going to be the last one like this, where it's just a circle that I do. -5 to 1 square root 16 minus x plus 1 squared dx. There are shortcuts you could use, by the way. They tell you it's a circle again. They tell you it's a circle. So for example, -5 to +1, that distance is 6. So like this distance on the base here is going to be 6 this time. So it's probably radius 3, right? And as soon as you know it's a half circle with radius 3, you're pretty much done. But we can type this in here. So this is supposed to be 16. I can type in 6. And this is supposed to be x plus 1, like that. And make it bigger. So there you go. There's your half circle. Oh, I stretched it. Oh, I didn't know you could do that on Desmos. That's interesting. Uh, oh, wait, it says to 1? Oh, oops. Well, glad I caught that. Well, I'm glad somebody caught that. -1 to, or sorry, -5 to -1. I thought it was going to be the whole half circle, but it's not. Look at the picture here. So if you're actually looking at the picture, and I don't know why I put an equal sign here. Um, the area, right? This, I'm dealing with negative numbers. You've got like -1 somewhere, which is negative 2, 3, 4, 5. -5 like that. But if you actually look at this graph, right, -1 is actually at the top of the circle here. It's actually like this. And then it comes down, and where is that? Looks like 3, right? That's the worst circle I ever drew in my entire life, right there. But I'm not redrawing it because I'm lazy. So the whole half circle is actually -5 to +3. So the part that we're talking about is only this part. So they are making this a little bit more complicated, right? It's a circle, but actually it's a quarter circle. So when you go to find this integral, you would say that it's 1/4 of a circle with radius. What's the radius of the circle? Right? Hopefully you can look at this picture here, and hopefully you can see that the radius is 4, right? Um, is that obvious? Is it obvious that it's 4? Uh, on this graph here, right? Like if you calculate the distance from here to here, that's 4. If you look up at the height, that was 4. Again, that's hard to read. Of course, this distance is also 4. So you should be able to tell that that's a radius 4 there. So that's a radius 4. Okay, so it's a quarter of a circle. So it's a quarter of a circle this time instead of a half. That's fine. So that's 1/4 of pi r squared instead of a half. So 1/4 pi r is 4 squared. So 1/4 times pi times 16. You work that out. That is going to be 4 pi. And that's what they're going to want for the answer, 4 pi. No decimal there. All right. So let's see here. There's another one that's just the same. Just going to cheat. It was another quarter circle. Okay. And so that's it for these geometric ones. So what we've got now is a properties of integrals thing to worry about. And I think I did this in one of the lectures already, but we're going to write them down anyway. So properties of integrals that you're going to need to know. I'm not going to number these in any particular way. I feel like we did these. Oh no, we did sums, I think. I don't know. Anyway, so the integral from a to b of f of x dx plus the integral from b to c of f of x dx is equal to the integral from a to c of f of x dx. That's really obvious when you look at a graph of a picture here. So like if I draw a little picture just to illustrate this. So if you have an A somewhere, you have a B somewhere, you have a C somewhere, and then you look at your graph, then you've got 3 pieces here. Well, no, you have 2 pieces actually. Oh, pink's fine. So you've got area from A to B, and then you've got this area from B to C, right? So if you have the area from B to C, that's this integral. If you have the area from A to B, that's this integral. And then if you add them up, what are you going to get? Well, you're just going to get the entire integral from A to C, which is what this is, right? So I don't know how to illustrate that on the graph. I think the easiest way will be something like this. So like A to C, A and C, right? So we go all the way, the whole thing is A to C. So hopefully that makes sense, that should be a property. This is going to be provided that all of the integrals exist. I should probably put that disclaimer here. So assuming all integrals exist, right? We haven't really talked about integrals not existing, but what if there is no integral from A to B that's not a number? Well, if it's not a number, then the rule doesn't make sense. All right. So that's a rule that you're going to need. And another rule. Oh, also just to be clear here, something that's helpful to remember is that you're looking for this number and this number to match in order to use that formula. All right, next rule. So another rule, if you have an integral from A to B of f of x dx, actually like this, and you add an integral of f of x plus g of x, then that is equal to the integral from A to B of f of x dx plus the integral from B to C. Wait, what am I doing? There's no B and no C, sorry. A to B of G. So what this is saying is if you want to integrate like a function and another function, you can just do them separately. Okay. This comes directly from the properties of sums. When we were talking about sums, I don't really want to like get too much into it, but like if you have an integral like this, if you go like f of x I plus g of x I, and then they're all multiplied by a delta x, right? That would be the sum of f of xi delta x plus the sum of g of xi delta x. Okay, so rules like this we learned for sums, and they apply directly to definite integrals as well, because definite integrals are defined in terms of sums. Okay, so this one should make sense. It's really easy to use. It's also the same rule that you have for derivatives. Makes perfect sense. Here's another one. A to B of, let's say, k f of x dx. If you've got a constant here, you can pull it out. Like that. So that's a simple rule. Again, it comes directly from the equivalent rule for sums, where if you had a sum of k, I'll say f of xi, that was equal to k sum f of xi. Or any sum, right? It doesn't even have to be a function. But it didn't even have to be a function like that. You could use like AI, whatever it is, right? So that's why the rule makes sense. Another rule, what's another rule? So we did sums, we did scalar multiplication, we did this first one, which was, different than the others. What other rules are we missing? I'm trying to think here. Oh yeah, here's a basic one. So this would take a little bit more to prove it, and I'm not going to do it right here. But it turns out that here's a rule that you might need. So you can flip these a and b around, but if you do, it makes the result negative. So it'd be negative integral b to a of f of x dx. Now, what does that mean? Right? Like in the pictures that we drew, we always drew a on the left and b on the right. And when we did that, we were calculating an area. Well, it turns out that if you put them in the wrong order, B and A, that what happens is it actually gives you the negative of your answer. So that's just what happens mathematically. Okay, so I'm not going to prove that one right here, but you may need it in order to solve these problems. Okay, now using these basic properties, what are the problems going to have? So what the problems are going to do is they're going to actually, let me just say what the point is. Problem type. So the problem type is going to be that they tell you the value of one integral or two integrals, and they ask you for the value of a different integral. So they doesn't say they tell you the answer, or they tell you the value of one or two, typically, could be more, but one or two integrals is usually what it is, and ask you for a third for another one. So the idea is that if you apply the correct rule, you'll be able to calculate it from what you know. Correct property. You should be able to figure it out. Right? What do they look like? Well, like this. Here's an example. So again, this is straight off of the homework. So they say determine the integral from k to 2 of f of x dx. All right, so here's a question for you. What is f? What is k? Think about it for a second. What is f? What is k? You don't know, right? Me neither. They didn't tell you. You must not need to know, right? So just because you see like this f of x and you say, oh, we don't know what the function is. Oh, they have a k. I don't know what k is. Yeah, you're not supposed to know. They don't want you to know. It's just an unknown number or an unknown function, whatever it is. All right, so they say determine this integral given, and they give us the integral from 2 to 9 of f of x dx. I didn't leave myself enough room. Let me move this over. Okay. Given that this integral is -7 and this integral 9 to k of f of x dx equals 1. All right. So when you see three integrals like this and you see like numbers that match, like the k here and the k here, that's a clue that you should probably be using like this first property here, right? Where you've got the upper limit here and the bottom limit here. That's just a clue, right? So we should know that this is what we're using. So just recall the formula, right? It was a to b of f, whatever the function is, plus the integral from b to c of f dx equals the integral from a to c of f of x dx. Now to write this out, make sure you know which ones match, right? The b and the b, like there. So notice which limits match. In this case, it's the top limit here and the bottom limit here. So when you're writing this out, be careful, right? So when I look at this right here, I see a top limit of k and a bottom limit of k. So when I've got these three things to write out, so we should be able to write it out and have it work out. So let's try it. So write it out. Oops. So write out something like this formula. Right. So I identified the matching limits. So this first one, it's the top limit. So that should be this one. So I'm just going to write the integral from 9 to k of f of x dx. I don't want to write what it equals. I just want to write that. Plus, then you've got the one with the bottom limit, which is this one. So that's the integral from k to 2 of f of x dx equals. The other thing you can notice about these, let me pick a different color, orange maybe, is that the limits here, the a and the c, are the other limits from the left-hand side, right? The a is down here and the c is here. So I should have the limit 9 and the limit 2. So according to the formula, this would be, and you have to be careful, right? The top limit here is the top limit here, and the bottom limit here is the bottom limit here. So this is actually what I got is 9 to 2 of f of x dx. Okay, now you have to be careful here, right? That's what the formula says. This is 9 on the bottom, 2 on the top. They asked for, well, they didn't ask for it, but give me 2 to 9. And this is 9 on the bottom, 2 on the top. This is 2 on the bottom, 9 on the top. So, we're going to have to be careful here. So this is what we get, right? Just applying the formula where this, top limit here matches the bottom limit here. And then the others limits, the 9 and the 2, go here, 9 and 2. So write out something similar to the formula. What are we trying to find here? What are we trying to find here? Well, what are we trying to find here? We're trying to find the limit here. Determine the integral from k to 2 of f of x dx. That's actually this right here, right? K to 2 of f of x dx. This is what we want to find. So I want to just say, this is what we want. Okay? Now, that's what we want. What do we have? Well, we should know this. Nobody saw that. And we should know this. Okay? So we're going to fill in numbers for there, and we're going to have to be careful, but we can do it. So let's try to do this. So what's that first one that I say we should know? It is the integral from 9 to k of f of x dx. Where is that? 9 to k. 9 to k. It's actually 1, right? We know this one. It's 1. So let's fill it in. So this is going to be 1 plus the one we're looking for equals, okay, what are we going to do about this? What are we going to do about this? Because this is 9 on the bottom, 2 on the top. And this is 2 on the bottom, 9 on the top. But don't we know a way to deal with that? I think we do, right? If you scroll up a little bit, look at this. If you want to switch the top and the bottom limits, like here it's a on bottom, a on top, b on top, b on bottom. You can switch them, you just have to add a minus sign. Okay, so I'm going to do this in 2 steps. We should know this, but it's actually equal to negative 2 to 9 of f of x dx. And that was using a property. We had to use that property there. to switch the limits. So, okay, now we should know it. All right. So what is the integral from 2 to 9? 2 to 9 is going to be -7. So let's write this out again one last time. It's not actually the last time, I lied. So we have k to 2 of f of x dx. We used a property here to switch the signs. Now we have a negative, so we have a negative, and then what was this integral? It was simply -7. Okay, so I've got 1 plus the integral from k to 2 of f of x dx is equal to +7. And we are trying to find this. Remember the goal? Solve for this. So you're just going to subtract the 1 over to the other side using, basic algebra. So k to 2 of f of x dx is going to be 7 minus 1, which is 6. Okay. So that is tricky. That's tricky, but we did it. You could have saved yourself some effort, by the way, right? What you could have done here is, at the time that I substituted this 1 in, right? I said 9 to k, what's that? 9 to k is 1. So I put a 1. And then here I said, oh, this is 9 to 2. We don't know 9 to 2. We only know 2 to 9. 2 bottom, 9 top. I mean, you could have just said, okay, well, if 2 to 9 is -7, then 9 to 2 is just going to be +7, right? We know from the theorem here that it just adds this minus sign. So just makes it positive. So you didn't have to really write it out in as much detail as I did here. I could have just written +7 right here, and that would have been fine. Okay. Regardless, we solved it. We got a 6 for our answer. I submit that. I got it right. I'm a genius. Let's do another one. All right. So hopefully it'll make more sense this time. Let's try another one. So they determine same exact problem, k to 4, given 4 to 9 is -9, and 9 to k of f of x dx is -3. So again, this is just like last time where you need to write out something that makes sense. So remember, you're looking for the two that match. Bottom is there, top there. And so those are the two that go on the left. So I should have integral from 9 to k of f of x plus the integral from k to 4 of f of x dx, right? You have these matching ones here and here. And then it would be equal to the integral of f of x dx. But what would we put for the limits, top and bottom? And remember, what you do is the bottom limit is here and the top limit is here. So 9 on bottom, 4 on top. And don't worry about the fact that this is the smaller number. That's weird, but the theorem doesn't require that this is a big number on top. Okay, so this is what your theorem says. That's from the property, what I called property 1, but and then we should fill in our numbers. Let's do it in a more efficient way. So we got, let me just get a highlighter here. So what's this integral here? I didn't actually see what we were looking for. Hold on. Is that what we're looking for? No. This is 9 to k. So that's this one right here. This one right here. So the value is -3 plus this one, k to 4. That is what we're looking for. So I'm just going to write it again. A24 equals, and then I've got 9 to 4 here. And remember, you can hopefully, as you're doing these, you're going to get better at this. This is 9 to 4. This one's 4 to 9. So what are you going to have to do to the number here to fill it in, right? It's not going to be -9. It would be -9, but we have to change the sign because this is 4 on bottom, 9 on top. This is 9 on top, 4 on bottom. Change the sign. So it's going to be actually a +9 there. And that's from, that property. I think we called it 4, right? So there you go. So again, you're going to solve for this. You're going to move it over to the other side. So you just do +3, +3. And you get the integral that you're looking for is going to be 12 using algebra. So we did that one a lot faster, right? But it's kind of sneaky about getting that value for that, about getting that +9 there. Okay, I see another one that's again the exact same problem, so I'm not going to do it. I see another one that's the exact same problem. I mean, it really is just the exact same problem like 5 times in a row. Okay, I mean, that's it. So you basically have, on that homework assignment, you've got a few of these. One of these, maybe 2 of these, a couple of these right here where they give you the formula but not the picture. And then probably, like, you might have 4 of these actually, 4 of these, but they're identical problems each time. So the exact work that I did here should help you solve those. And yeah, I think that's it. So good luck. Yeah, good luck. Come to office hours if you have questions.